All right, for this section, we're going to review how to use the unit circle to evaluate trig functions and then also inverse trig functions. So first, for evaluating trig functions, you'll need to remember a few things about the unit circle. I would recommend you either print a unit circle from the internet that's already filled out or print a blank one from the website and fill it out yourself, just so you have a full-size page that you can keep in the front of your binder and refer to all the time. So a couple things that we want to remember is that on the unit circle, the x-coordinate is cos, evaluated at that angle. The y-coordinate is sine, evaluated at that angle. And then tangent, evaluated at that angle, is the y-coordinate divided by the x-coordinate, or you could say sine divided by cosine. And then we do have three other trig functions. We have secant, cosecant, and cotangent. And in the purposes of simplifying trig expressions, we would say that secant is the same as 1 over cos. But when we're talking about evaluating trig functions, I would say that secant is the flipped version of cos, so that if cos was 1/2, then secant would be 2 over 1. And I'm going to go ahead and write that on my paper because I think that's an easier thing to remember. So I'm going to write flipped version of cos, flipped version of sine, flipped version of tangent. Goodness gracious. All right, so those are the other three trig functions. It's kind of typed out in your summer assignment, but just to make sure we kind of understand how evaluating trig functions using the unit circle works, if I wanted to know what cos of pi fourths was, I would locate pi fourths, and then cos would be the x-coordinate, so it's root 2 over 2. If I wanted to know what cosecant of 7 pi 6 was, I would go to 7 pi 6, I would take the y-coordinate, because that's sine, and then I would flip it, and I would get negative 2 over 1. If I wanted to know what tangent of 5 pi thirds was, I would look over at 5 pi thirds, I would take the y-coordinate divided by the x-coordinate, and I would simplify it, and that would be tangent. So that's kind of how evaluating trig functions works. Now for me, as I go through this, I'm going to not use the unit circle so that I can show you how I mentally picture it in my head to do problems like these, okay? So the first, for these examples, we're going to be evaluating. That's what the instructions would say. And what I mean by evaluate is simplify it until you have one numeric answer, or as simple numeric as you could. So the first example is going to be 2 tan squared of 5 pi thirds plus 3 sine squared 5 pi 6 minus cos squared pi. So the first thing I would do in this problem is I would rewrite the problem, because when it's written as tan squared, it kind of feels like you're squaring the tan itself, which doesn't make sense because tan is kind of like an operation. So I'd be saying division squared, which is weird. So I'm going to rewrite this as 2 times tan of 5 pi thirds. And then once you know what tan of 5 pi thirds is, then you're going to square that expression. And then 3 sine of 5 pi 6, ooh, my handwriting, squared. And then minus cos pi squared. Okay, so I'm going to picture the unit circle. I know that 1/3 is here, 2/3 is here, 3/3 is over here, 4/3, 5/3, 6/3. So I'm going to picture it being kind of right there. 5 pi thirds is right a little bit, down a lot. So that's right a little bit, down a lot. And then I know that tangent is y divided by x. Whenever I do tangent, I ignore the 2's because I know they would cancel. So tangent would be negative root 3 over 1. So I've got 2 times negative root 3 over 1, which is just negative root 3 squared. Okay? 4, 5 pi 6. 5 pi 6 is a little bit less than 1. 1 pi is over here. So there's my 5 pi 6. That is left a lot, up a little bit. Left a lot, up a little bit. And so that means that sine of 5 pi 6 is 1/2. And then pi is over here. That means we have our radius of 1, so we go left 1, up or down 0. And cos is the x coordinate, so that's negative 1. So I might not draw these pictures perfectly, I might not write out the coordinates, but that is what's going on in my head when I'm doing a problem like this, and I do not have the unit circle right in front of me. All right, negative root 3 times negative root 3 is just 3, so I have 2 times 3. 1/2 times 1/2 is 1/4. Negative 1 times negative 1 is 1. So I have 6 plus 3/4 minus 1. 6 minus 1 is 5, so this is 5 3/4, or we could say 15/4. I'm going to default to improper fractions, just because I feel like that's more common in math. Okay, so if I want to type this in, first I need to make sure I'm in radians because I did these in radians. And then I have to be careful about how I type this in. So you'll notice that I'm kind of typing this in like that expanded form instead of that like shortcut form. Plus 3 sine 5 pi 6 squared minus cos pi squared. So, oh goodness gracious, I did 5 times 3 when I converted it. It should be 5 times 4 is 20. 20 plus 3 is 23/4. Whew. You guys making these videos during the summer? All sorts of summer brain mistakes. Okay, second example. We're going to do cotangent of negative pi over 6 plus tangent 10 pi thirds minus cosecant negative 5 pi over 2. Okay, so what I did in this example is I gave you some angles that are negative or too big for the unit circle or whatever, so you could practice finding a coterminal angle that is on the unit circle. So to find a coterminal angle, we just have to add or subtract 2 pi to find the angle that would have actually shown up on the unit circle. So this one, you might be able to think of it just fine. You could think of it as going backwards. So if positive pi 6 is up here, then negative pi 6 is down here. And so that means that this would be 11 pi over 6. That's one way to think of doing the problem if you're going to do it visually. The other way to do it would be to say I have negative pi over 6. I'm adding 2 pi to that to find the coterminal angle. And so what I have is negative pi over 6 plus 12 pi over 6. That was me getting a common denominator. And then negative 1 plus 12 is 11. So, oh, I'm doing 11 pi over 6. 10 pi thirds. 10 divided by 3 is bigger than 2, so that means that's bigger than a full circle. So I'm going to subtract 2 pi. So that means I've got 10 pi thirds minus 6 pi thirds. So that is 4 pi thirds. And then negative 5 halves is negative, so I'm going to add 2 pi. So that's negative 5 over 2 plus 4 pi over 2. That's going to be negative pi halves. That would be negative 1. So I'm just going to add another 2 pi. So I'm adding another full circle. So if I have 8 pi halves minus 5 pi halves, that's 3 pi halves. Okay, so now I can kind of go through and do the part that I was thinking of where I'm picturing the unit circle in my head. So here 11 pi 6 is right there. I go right a lot, down a little bit. Right a lot, down a little bit. And so cotangent is x divided by y. So I ignore the 2's. Root 3 divided by negative 1 is negative root 3. So here I've got negative root 3. 4 pi thirds. 1/3 is up here, 2/3, 3/3 is the line, 4/3 is over here. So that's left a little bit, down a lot. Left a little bit, down a lot. So tangent is y divided by x. I'm ignoring the 2's. I have negative root 3 divided by negative 1, which is positive root 3. And then 3 pi halves is this line right here, that quadrant line. And so that goes left and right nothing and down 1. And cosecant is the flipped version of sine. So if sine is negative 1, I have to think about that as a fraction. That'd be like negative 1 over positive 1. So I'm minusing, and then I'm flipping that fraction, so positive 1 divided by negative 1. So I've got these cancel, and then minus negative 1 equals positive 1. Okay. This one is interesting to plug in because we don't have buttons for cotangent and cosecant. So to plug these in, now the bummer about this is sometimes these are hard to plug in the event that you have something that shows up as undefined. So just because you can't plug it in perfectly doesn't mean you didn't get it right. But this first one will be 1 over tan of negative pi 6. That's how you type in cotangent of pi 6. Plus tan 10 pi thirds minus 1 over sine negative 5 pi halves. Let me get 1. Okay. Last one for the evaluating trig functions, and we'll do some inverse. Okay, so we have sine of 11 pi over 6 minus tan of 5 pi over 6 times sine of sine of pi 6 plus tan 5 pi 6. Okay, so I'm going to go ahead and think about where 11 pi 6 is. I know that's just a little bit less than 2. So I go right root 3 down 1/2, right a lot, down a little bit. That was root 3 over 2. So sine of that would be negative 1/2. That's what I've got first. Minus. And then 5 pi 6 is just a little bit less than 1, so that's left a lot, up a little bit. So left root 3 over 2, up 1/2. And so that would be 1 divided by negative root 3. I'm going to go ahead and write 1 divided by negative root 3 right there. Sine pi over 6. That's to the right a lot, up a little bit. And so that's positive 1/2. And then 5 pi 6, we already did that one. It's plus, and then negative 1 over root 3. Okay. Now for tangent, when you have a problem that says 1 over root 3, in calculus you can leave it like that. In pre-calculus we would have fixed it. We would have said 1 over root 3 needs to be rationalized. We would have rationalized it by multiplying by root 3 on the top and root 3 on the bottom. and then we would have gotten root 3 over 3. So multiple choice answer, probably going to use this one. Free response answer is not going to matter. I'm going to go ahead and use this because it's what I'm used to, so it's more comfortable. Negative times negative is a positive. Okay. Now, to finish this problem, we have a couple different ways you could, that was supposed to be a 3. We have a couple different ways you can go about this. So I can FOIL it right now and kind of see what I get, what happens. Or I could get a common denominator between these two, so that I have like a fraction here and a fraction there, and then the numerators are going to need to be FOILed. It just kind of comes down to what you want to do. I would say I'd rather get a common denominator when the denominators are 2 and 3 than when they get bigger in a second when I like FOIL it. So I'm going to go ahead and multiply this by 3 over 3 and 2 over 2 and 3 over 3 and 2 over 2. So now I have negative 3 plus 2 root 3 over 6. 3 minus 2 root 3 over 6. Okay, so when I multiply this fraction times that fraction on the bottom, I'm going to get 36. 6 times 6 is 36. Okay, now I can go ahead and multiply the top. So negative 3 times 3 is negative 9. Negative 3 times negative 2 root 3 is positive 6 root 3. 2 root 3 times 3 is 6 root 3. Positive 2 root 3 times negative 2 root 3 is negative 4, right? That's the 2 and the 2, and then the root 3 and the root 3 is 3. So that's what I've got there. Okay, so I have negative 9 plus 12 root 3, so 6 roots of 3 plus another 6 roots of 3 gives me 12, minus 12. Over 36. And 9 plus 12 is 21. And that should be my exact answer, and I just want to check that because I don't feel great about that funky answer. Ugh. Sine 11 pi 6. Is that the beginning of the problem? You guys were just watching me miss that, weren't you? Still no bueno. You guys, I figured it out. There was a typo at first, but also, that's a 12, and I wrote 2. Whew. So, we really did get it right. Okay, let's move on. For evaluating inverse trig functions, this is typed up in your packet, but this might be something you could want to add to your unit circle. So if you are evaluating a tan inverse or cotangent inverse or sine inverse or cosecant inverse, then you can only have answers in quadrants 1 and 4. So I'm just going to write sine inverse and tan inverse, but we know if we were doing cotangent and cosecant, it would be the same. And then if you are doing a cos inverse or a secant inverse, your answers can only be in quadrants 1 and 2. So that's the first part of it. The second part of it is if you have a sine inverse or a tan inverse, then your answers have to be the negative version of the angle. So we wouldn't call this 11 pi 6, we would call it negative pi 6. We wouldn't call this 7 pi fourths, we would call it negative pi fourths. negative pi thirds, negative pi halves. So when we are doing the inverse trig problems, that's what we have to keep in mind. So we're going to go ahead and do 2 examples of this, because this video is long enough. So tan inverse of root 3. Since it is a tan inverse problem, that means I'm looking in quadrants 1 and 4. Quadrant 4 is going to have negative answers for tan because one of the coordinates has a negative, so that means I am isolated in quadrant 1 to find this answer. For it to have root 3, then I know it's not going to be this one or this one. I know it's also not going to be this one because there's no root 3 in there. So my 2 options, if I'm looking for what angle is represented by tan inverse of root 3, would have to be one of these 2. So then I have to think about y divided by x needs to simplify to be root 3. So my options are 1 divided by root 3 simplifies to be plain root 3, or root 3 divided by 1 simplifies to be a plain root 3. And so the answer is this one. So tan inverse root 3 is pi thirds. All right. Number 5. We're going to do secant inverse of negative 2. Negative 2 is going to be hard for me to find on the unit circle because this is secant inverse, and so what I'm going to do before I even start the problem is I'm going to say, no, that's not the problem I'm talking about. I'm talking about cos inverse of the flipped version of this fraction. So I'm talking about cos inverse of negative 1/2. Okay, so since it's cos inverse, I'm looking at quadrants 1 and 2. Quadrant 1 only has positive answers, so I'm looking at quadrant 2. Cos is the x-coordinate, so I'm looking for an x-coordinate of negative 1/2, and that is right here, so that's 2 pi thirds. All right, and then again, these answers are easy to check if you don't have any typos. So that would be pi thirds. And then over here, secant inverse, I can't type in, so I'm going to type in cos inverse of negative 1/2 is that, and 2 pi thirds is the same.